So now we're going to have a look at how to perform the Wilcoxon assigned rank test with paired data. And as we talked about before, with the signed test, paired data is where we have the same information about the same subject or person, and usually it's before and after something has happened. Again, we're going to be getting our critical value from the formula booklet. Remember that this is on page 25 in the formula booklet, and always double check that you are reading the correct table. So, same as with the single sample data with the Wilcoxon assigned rank test and a lot of other tests that we do, we have a one-tail hypothesis test and we also have two-tail hypothesis tests. And we're going to start off by having a look at the one-tail hypothesis test. So our first example, we have an athletics coach wishes to test the value to athletes of an intensive period of weight training, and so selects 12 400-metre runners from the region, and records their time in seconds to complete this distance. They then undergo the programme of weight training and have their times in seconds for 400 metre measured again. The table below summarises the results. So here we have the first athlete, we have how long it took them to do 400 metres before the weight training, and we have how long it took them to do the 400 metres after the weight training, and the same for B, C and D and so on. So then we're told to use the Wilcoxon assigned rank test at 5% significance level to investigate the hypothesis that the training programme will significantly improve athletics times for the 400 metres. So in the same way as our hypothesis changed for the signed test, it changed in the same way for the Wilcoxon assigned rank test. So our H0 is going to be that the median difference ends up being 0. So the difference between these two groups is 0. And then we need to think about which way round is going to be bigger and which way round is going to be smaller. As I did with the signed test, I'm going to be doing the top value minus the bottom value. So I'm going to be doing before minus after. And if we think about the values that those two take on, we're wanting athletes to improve their times, which means that we're wanting them to get quicker. So we're wanting their times afterwards to be small and their times before to be big. And if I'm doing a big number minus a small number, that's going to end up being positive. So that's going to be greater than 0. So my H1 is going to be that the median difference is greater than 0. Now we need to actually find those differences between the values. Remember that you can use your calculator to help you to do this. So if we go into the statistics function, delete anything that you've already got in there. Then we're going to type the before times into list 1. So 51, 49.8, 49.5, 50.1, 48.9, 52.4, 50.6, 53.1, 48.6, 52.9, 53.4, and then in list 2 we're going to type in their after times, so 50.6, 50.4, 48.9, 49.1, 51.6, 47.6, 53.5, 49.9, 51, 48.5, 50.6 and 51.7. So I've obviously typed something in wrong here because I have one extra in one column than I do in the other. So I need to go back and double check that I've entered everything incorrectly. So 51, 49.8, 49.5, 50.1, 51.6, so it's there. 51.6, 48.9, sorry about that. Then have a good overall check that everything has been entered incorrectly. Like I just pointed out, I knew that I'd typed something in incorrectly because I had different amounts of data in each list. Little things like that mean that you can quickly spot that you've done something wrong, but always make sure that you have double checked that you've put the numbers in correctly, because we are going to be getting all of our differences from the calculator now. So as I have explained before, if we go to list 3 and go all the way to the top of list 3, so that where it says list 3 it's highlighted, and then we type in list, remember to get list it's shift and then 1, and we're wanting to do list 1, our before times, minus shift and then list again, 2. So we've got list 1 minus list 2, and when I click Exe now, list 3 has been filled with the differences. So now we need to write those differences down. So we have 0.4 minus 0.6, 0.6, 1, 0, 1.3 minus 1.1, 0.7, 2.1, 0.1, 2.3 and 1.7. Now, in the same way as we had with the sign test, single and paired, and with the single Wilcoxon sign rank test, any value that's a 0 should be a dot, and we're going to ignore that piece of data now. So that one there, fifth one down, we're going to be ignoring. And in the same way as we had for the single sample of data, I'm just going to move this down a little bit. So as I said, that first list is the differences, and we're going to be ranking them so that our first list is our rank plus, and we have rank minus. And again, similar to how we did with the single sample, we are going to be ranking them from their size from 0, ignoring what sign they have. So the closest number I have to 0 is 0.1. So that gets the rank of 1 in the plus column. My next smallest value is 0.4, so that's going to get the rank of 2, again in the plus column. My next biggest value is 0.6, and I have 2 of those, so they're going to be getting the rank of 3 and 4, split between the 2 of them, which means that they both get the rank of 3.5. So the 3.5 for minus 0.6 is going to go in the minus column. Whoops, sorry. And 3.5 for the 0.6 is going to go in the positive column. So that's rank 3 and 4 gone. Rank 5 is going to go to 0.7 because that's my next biggest number. So that's all my 0 points gone. So the next biggest one is 1. That gets the rank 6, again in the positive column. Then we have 1.1, and it's minus 1.1, so that's going to get the rank of 7 in the minus column. Then 1.3, that gets the rank of 8 in the positive column. Then 1.7, that gets the rank of 9 in the positive column. Then 2.1, that gets the rank of 10 in the positive column. And then 2.3, that gets the rank of 11 in the positive column. And just as a quick double check, here we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 athletes to begin with. We cancelled out that one there because that gave us a difference of 0, so we're not including that, and my maximum rank was 11. So then we need to add up the ranks again. So we're going to have a total for the plus ranks and we're going to have a total for the minus ranks. So the total for my minus ranks is 10.5. For the plus ranks, if I go into my normal calculator bit, so I've got 2 plus 3.5 plus 6 plus 8 plus 5 plus 10 plus 1 plus 11 plus 9, and that gives me 55.5. And remember, at the top of the page that has the critical values, there is also that formula that these two numbers should add up together to give, which is the half of n plus 1 formula. So remember, we had 11 pieces of data that we're actually looking at, so these should add up to a half of 11 times 12. So a half of 11 times 12, which gives me 66, and 55.5 plus 10.5, oops, does give me 66. So I've definitely ranked everything and added those up correctly. So now, as we had before, the smallest of those two totals is our test statistic. So our test statistic is going to be 10.5. The critical value, having a look at page 25 in our formula booklet, it is a one-tail test. It is a 5% significance level, and there was 11 things that I was ranking. So where it says one tail across the top, I'm going to go to 5. Then I'm going to go down till I end up with 11 on the side, and that gives me a critical value of 14. So then, as my test statistic is smaller than the critical value, that means the difference between my two totals is big enough to reject H0 at a 5% significance level. There is sufficient evidence to suggest the average time to complete the 400 meters is quicker after the training than before. So now I'd like you to pause the video and give the Now You Try question a go. Remember to be careful and clear which way around are you doing your takeaway. Does that mean that your H1 is going to be positive or negative? Okay, so hopefully you paused the video and gave the Now You Try a go. So here we've got the table below shows the hours of relief provided by 2 analgesic tablets analgesic drugs in 12 patients suffering from arthritis. So there we've got drug A and drug B both being used on the same patient, and so on and so forth. So test at 5% significance level if there is any evidence that drug B provides longer relief than drug A. So we've got H0, the median difference is 0, H1, the median difference is less than 0. Because I'm going to again do the top one minus the bottom one, that's drug A minus drug B. Well, we want drug B to provide longer relief, so we want in drug B to be a bigger number and drug A to be a smaller number. And if we do a small number minus a big number, that should give us a negative answer, so the median difference should be less than 0 then. So then finding the differences, if I just show you my calculator, put in drug A relief times in list 1, drug B relief times in list 2, and then going to the top and put in list 1 minus list 2 and getting the differences in list 3. And then I've wrote them down here. You can see then I've done my ranking 1, 2, 3, 4, And then there was 2 minus 1.5s, so that's my little working out there that they should both get 5.5, and then 7 would be the next one, and then it continues. Then we need to add them up, so you can see at the bottom my total for my pluses is 7, the total for my minuses is 71. And again, in the normal part of my calculator, you can see that I just double checked. What should they add up to? They should add up to 78. Yes, they do add up to 78. So then my test statistic is the smallest of those two totals, which makes my 7 the test statistic. The critical value I get from page 25, 5% significance level, so where it says one-tailed, I'm going across to 5%. This time I'm going down to 12, which gives me a critical value of 17. So then as my test statistic is smaller than the critical value, that means the difference between those two numbers is big enough to say that there is a difference, so we're rejecting H0. At 5% significance level, there is sufficient evidence to suggest the average relief from drug B is longer than drug A. So now we're going to have a look at two-tailed tests, very similar. Again, we're going to be using the critical value table on page 25 to get our critical values. This time, however, we're going to be reading across from where it says two-tail with our significance level percentage instead of one-tailed. So here, the space to answer this question is on the next page. I am just going to extend it here though, so I can keep it all on one page. So we have, as part of her research into behaviour of the human memory, a psychologist asked 15 schoolgirls to talk for 5 minutes about my day at school. Each girl was asked to record how many times she thought that she had used the word nice during this time period. The table below shows the replies, so the true ones and the recorded ones. Wilcoxon sign rank test to investigate whether schoolgirls tend to underestimate or overestimate the frequency of which they use a particular word in their verbal description. Use a 5% significance level. So because it hasn't designated one or the other, that tells us that we are doing a two-tailed test. We're seeing if it's an under or over, we're not seeing if it's one way or the other. I'm still going to write down which way I'm doing my takeaway, just so that the examiner can be aware that I'm doing it this way round. And back into the statistics function, we are now going to put the true values into list 1. And the recorded value into list 2. Again, double check that you've typed everything in correctly, because we are going to be getting the differences from our calculator. Then at the top where it says list 3, we're doing list 1 minus list 2. There we go. So our differences we have 3 minus 1 minus 2 minus 6 minus 4, 0 minus 4, 3, 1 minus 4, 4, 7, minus 1, 1 minus 3. And again, that 0 is going to become a dot. So we've got rank plus and rank minus. So looking through here, smallest difference is ones. I've got 1, 2, 3, 4, either ones or minus ones. So that's going to be 1 plus 2 plus 3 plus 4 divided by the 4 numbers, means that they all get the rank of 2.5. So that one for the minus one is going to go in the minus rank column. Then for this positive one here, that's going to go in the positive column. -1, that goes in the negative column, 1, that goes in the positive column. So then 2 is the next biggest one, which is just this one here. 1, 2, 3 and 4 have already gone. So -2 here is going to get the rank of 5 in the minus column. Then 3 is the next one, quite a few 3s. We've got 1, 2, 3 3s. So 5's gone, so the next rank is going to be 6, 7 and 8. Divided by those 3 numbers mean that they all get the rank of 7. So then this first 3 here is going to get the rank of 7 in the plus column. This rank here, this 3 here, sorry, is going to get another rank of 7 in the plus column. And this -3 here is going to get a 7 rank in the minus column. So the next biggest difference is 4. Again, a few of those. 1, 2, 3, 4. 8 was the last rank we used. So 9, 10, 11 and 12 divided by those 4 numbers mean that they each get 10.5. So 10.5 in the minus column for that -4. Same for that -4. And for that -4. And then in the positive column for that 4 there. So then the next biggest difference is 6 here, which is going to be 13 in the minus column. And then the biggest difference is 7, which is going to be 14 in the positive column. And just double checking, here we had 15 schoolgirls. One of them ended up being a dot, and I got to rank 14, so that should be right. So now we need to add up those ranks. So adding up the rank pluses would be 7 plus 7 plus 2.5 plus 10.5 plus 14 plus 2.5, which gives me 43.5. So my T plus. So my T plus is 43.5. Now adding up the ranks for my minus, 2.5 plus 5 plus 13 plus 10.5 plus 10.5 plus another 10.5 plus 2.5 plus 7. And that gives me 61.5. So there were 14 numbers that I was ranking here. So 14 times 15 divided by 2 means that my 2 totals there should add up to 105. 43.5 plus 61.5 does add up to 105. So I've just double checked there that they add up to the right amount. The smallest of those is my test statistic. So my test statistic is going to be 43.5. Getting my critical value from the critical value book on page 25. So this time looking across from 2 tail, where it says 5%, going down to where it says 14. So 2 tail, 5% down to 14 gives me 21 as my critical value. So this time, as the test statistic is bigger than the critical value, we are going to accept H0 at a 5% significance level. There is insufficient evidence to suggest the average word nice. So the average times recorded as saying nice is not the same as the true value. So now I'd like you to pause the video. It'll go on to the next page. There we go. Pause the video and give the last now you try question a go. Again, even though this time it doesn't matter which way you do your takeaway, it's still nice to know which way you've done it for knowing what your T plus and T minus should end up being. So hopefully you've paused the video and give the Now You Try a go. So this time, in a comparison of two computerised methods, A and B, for measuring physical fitness, a random sample of 8 people were assessed by both methods. This score, maximum of 20, was recorded as follows. So you can see there the same person doing method A and method B, and the same for each of the 8 people. So we're going to use the Wilcoxon signed rank test at a 5% significance level to test whether the two measures of fitness give similar results. So our H0 is that the median difference is 0, our H1 is that the median difference is not equal to 0, and I'm doing method A minus method B. You can see, if I go back to the stats part of my calculator, I've put method A in list 1, method B in list 2, found my differences in list 3, and I've wrote them down here. Then I've ranked them, splitting them between rank plus and rank minus, and totaled them at the bottom. And back in the normal part of my calculator, I double checked they added up to the correct value, which was 28, and they do. So the smallest one of those is my test statistic. In this case, that is 3. So my test statistic is 3. Looking up the critical value on page 25, going across from 2-tail to 5% and then down to 7, because one of them ended up being a dot, so we only ended up with actual 7 pieces of data that we were ranking. We get a critical value of 2. So then, as the test statistic is bigger than the critical value, we accept H0 at 5% significance level. There is insufficient evidence to suggest that the average fitness result is not the same for method A and method B. Thank you very much for listening.